This is going to be easy.
On you mark! Get set! Go!
Walao eh, her car's so fast oh. I might lose.
Yay, I won!
This doesn't make any sense. How did I lose? We have the same make and model. What's the difference between our cars, huh?
Welcome everyone to the Anonymous TV show. Wow, what an intense race that is. I'm sure and curious how Ashley's car went that fast.
Well, the secret lies between the solenoid and the magnet attached to the car. To make things easier, I will explain it with a model made by the Attract O band. A solenoid is a device consisting of a coil of wire wound in a helical shape connected to a battery. As electric current flows through the wire, it generates a magnetic field around the coil. For now, we will let Miss JJ brief with us more details of the model.
Thanks, Mr. Daniel. To understand better how the model operates, we need to look at two key principles, Faraday's law and Lenz's law. Faraday's law says that the electromotive force, EMF for short, induced in a coil is related to how fast the magnetic field around it changes. In the model, as the solenoid's magnetic field changes, it induces a voltage that helps move the car. By increasing the strength of the magnet or adding more turns of coil, we can increase this induced EMF, making the car move further. Lenz's law states that the induced current's direction is such that it opposes the change in the magnetic field that caused it. In our model, the current induced in the solenoid creates a magnetic field that interacts with the magnet on the car, which causes the car to be propelled forward when the switch is on. In Lenz's law, it states that induced current will always flow in the opposite direction of that which produced it. Hence, by applying the right-hand grip rule that is used to determine the polarity of solenoid, our curled fingers will represent the direction of current flow in the coil, whereas our thumb is always pointing towards the North Pole. This magnetic field acts similarly to that of a magnet, exerting attraction or repulsion force on nearby magnetic materials. In essence, a solenoid functions as an electromagnet, converting electrical energy into magnetic energy. That's all from me, and I'll pass it back to Mr. Daniel.
Thanks, Miss JJ, a lot for the detailed explanation.
Wow, that sure is a lot to be digest. But to be honest, what does that have to do with Ashley winning the race?
So, as we all can see, Ashley and Rebecca used the same model for their car named Nimbus 2000, sponsored by the He industry, which means they have the same amount of magnet. But Ashley uses the latest model of solenoid named Solenoid 14500 TOC, while Rebecca used the Solenoid 8500 TOC. Hence, Ashley's car has more turns on copper wire coil, while Rebecca's car has fewer coils. When current flows through the coil behind Ashley's car, the increased number of coils results in a higher number of cutting of magnetic flux compared to Rebecca's car. This produces a stronger magnetic field, exerting larger force on the race car, causing Ashley's car to move further.
Oh, I understand now. Gotta admit, Ashley is a talented car racer. But I have a question for you. What if Rebecca uses the solenoid 14500 TOC in the race as well? Is there any way for Ashley to still win the race?
Of course, Ashley can use the Nimbus 3000, which has a larger amount of magnets, which increases the total strength of magnets. A higher strength of magnets will also increase the cutting of magnetic flux, resulting in a larger induced EMF. So, a larger force will be produced, propelling the car further.
Fascinating. Never thought that I could learn physics from a race. And that's all from the Anonymous TV show. And we hope to see you again. Bye!